welcome to Dave's Think Tank. In my last video, I spent some amount of time praising the Vector for never giving me any problems. So, before I'd even finished filming the video, it started giving me problems. In the video, I changed out some old capacitors in the voltage regulator board for new, and I did a few recommended modifications to improve the board's grounding and distribution of power. Then when I turned it on, there was a new hum in the speakers, as well as a new buzz whenever the Squawk and Talk here would speak. So this is not unusual with old electronics. You fix one thing and suddenly electricity is flowing around the boards in ways it hasn't before, and the next weakest link in the chain breaks. I tried taking out the grounding changes I had made to the voltage regulator board, hoping it would just go back to the way it was, but that made no difference. So the next time I pull that board out, I'm going to have to put those back. I'm in no big hurry for that, though. Then over the next few days, both the hum and the buzz got worse. The hum was quite loud when I turned the machine on, but both it and the buzz would almost disappear over the next 5 minutes or so. I always hope it'll just be one of these connectors and all I'll have to do is wiggle it a bit to find a good spot, but that wasn't working. I was going to have to actually do something to fix this. The weak spots in these old boards are the connector, the volume controls, and the aluminum electrolytic capacitors. I'd already ruled out the connector and the volume controls seemed to work okay, so I figured I would tackle the massive job of swapping out all of these electrolytic capacitors. The reason it's a massive job is there are 16 of these capacitors to be desoldered, removed, and replaced. The first job is to order them. I usually go to a Pinball website for this kind of thing. Many of them have packaged kits supplying all 16 capacitors with no effort on your part to find the right ones. But I wanted the job done by the weekend, and a package from the US usually takes a couple weeks. So I went to Mouser to look up each one. The final price, including shipping, was almost exactly the same, about $30 Canadian, but I got my capacitors the next day. If you're ordering them individually, just look in your Pinball manual for the Squawk and Talk module page. You'll find they have 16 parts labeled as electrolytic capacitors, such as this 171 microfarad 25 volts. And actually, now that I look, C36, C43 are not labeled as electrolytic, they're just labeled as capacitors, but why, I don't know. Order them anyway. It's not difficult to find exact matches, but remember you can always go up in voltage, and although you likely want to match capacitance, it's generally safe to go up slightly in microfarads. Now before you start, you need to recognize two sources of potential disaster on this board. Number one, do you see any difference between this capacitor, which I removed, and the modern one that replaced it? New capacitors all have an arrow on them pointing to the negative lead, but all the original capacitors have an arrow pointing to the positive lead. Why that is, I couldn't tell you. Just don't be fooled and solder the new capacitor in backwards. There's always a plus sign on the board to identify the positive end, so just make sure that the arrow is pointing away from it. The other thing you need to know is some of these capacitors need to be soldered on top of the board as well as the bottom. This board has traces on both sides. This is easy to do. Just solder from the bottom like usual and add a bit more solder and watch. As it heats up, it will disappear down the hole. Turn the board over and you should see a silvery dome of solder on both sides. So just be sure to check top and bottom for that solder dome. Now before you remove the board, you should take voltage readings at the test points. To find out if there are any problems, you can also compare these to measurements after you're done to make sure you didn't make things worse. My initial inspection of the capacitors showed that this one had some gunk growing on one end, which is never a good sign. My measurements also indicated there might be problems in the negative 5 volt circuit controlled by these two capacitors, which measured only negative 4.7 volts. So I replaced these three first. I put the board back in, but there was no change. So next I replaced the three capacitors up in this area. One of these is a 2 microfarad, so I replaced the other 2 microfarad, I think is this one here, since I had the package open anyway, and tried the board in the machine. Again, there was no change at all. I replaced the final 2 non-1 microfarad capacitors here and here. Tried it in the machine, and success. The sound was loud and clear without any hum or buzz at all. So, I did not replace these 7 1 microfarad capacitors. I still have them. I'll put them in sometime, but I'm not feeling any urgency. I'm a firm believer in if it ain't broke, don't fix it. Although I have noticed the volume of the speaking voice sometimes goes low. This could mean that the volume control here is going. I've looked into these, they're about 50 cents each, so I'm torn at the moment whether I should spend $20 on shipping $1 worth of parts. Anyway, let's play a game.
Vector. I am a PAC, Play Analysis Computer, for your vector game plan. Defender. Defender is down. Shoot for vector scan. Shoot for vector scan. Shoot for vector scan. Resume play. Shoot for vector scan. Shoot for vector scan. Weak shot. X. Y. Defender. Play. Defender is down. Please. Great shot. Hurricane storm. Why? Defender. Why? Dang it. Defender. Defender. Please. Shoot for vector scan. Great shot. Organ released. Please. Shoot for vector scan. Please. Z. E. Dang it. Vector Z, Y, X. Great shot. Hurricane storm. Y. Defender. Please. Defender. Dang it. Defender. Defender's down. Great speed. E. G. Dang it. Please. E. Please. Dang it. X. Hit the showers.